Hi, thanks for joining my talk on the Hitchhiker's Guide to Enterprise Microservices with Go. And I hope to talk you through, quite a topic in 30 minutes and 40 overall, to give you an impression on, why I think large enterprises, modern enterprises, should maybe start adopting Golang as a, business domain language to implement their microservices instead of the, the usual languages that have been there for the last decades or 2 decades at least. So my name is Leander. I'm a chief software architect. I work for Coavia. I'm located in Munich. I live south of Munich in the beautiful countryside of Bavaria. Not many people know that I'm actually a Berliner. I'm born here. I'm born in Pankow. But at some point in the old days, I moved to Bavaria, or I had to move to Bavaria. Nowadays, I, consult and work and program and build systems for large German enterprises. I myself am in the automotive sector mainly. Okay, so you can do the math. I work in Munich, automotive sector, so that can only be one. Colleagues of mine, they work in the insurance industry. They work for Allianz Insurance, for example. We do work for German Telecom. And what we see is that all of those big companies, they want to move in a new era. They want to move into a cloud-native era. They want to modernize, their internal systems. They want to modernize how they build systems. They go away from projects towards products. So, they innovate their technology. They educate their internal people again and all this. And what we usually do is, we kind of help those. And by coincidence, last week, I received an email from those lovely guys from Lotse. And what they tell you here and show you here is kind of the predicted enterprise cloud native adoption, what we see. And you see here in January 2020, which is kind of, today, it's this month, you see that if you are in the cloud native ecosystem as an enterprise at the moment, you're kind of the early adopters. And the mission we have, or the mission I think, large enterprises have and, should go on, is to be like under the early majority, maybe in January 23. So they have 3 years' time, right? Make sure, here's the link, make sure to read this blog post. I think it's, really readable and well explained why they should move. In summary, this is kind of this here. Well, enterprise cloud native. The term hyperscale, I don't know if you know all the term hyperscale, or sometimes called web scale. Well, it has something to do that, the systems we build nowadays, they have to cope with a lot more traffic, a lot more data, a lot more features. This has something to do with, digital products, and, a BMW or Adidas or German Telecom or Allianz. What they basically do is, they want to offer cool new features towards their customers. And of course, more customers, more traffic, more features. So the old way of operating systems and the old way of building systems is not that state of the art anymore. Those systems just can't cope with the amount of traffic data and so on they have to cope with. The next thing is what we call antifragility. If you build digital products, you have a problem. If those products don't run because you have not built them well or your infrastructure just died, you're not earning money. You're probably losing money. And you're probably losing customers, because the customer says like, well, this crappy service, it doesn't run, I go to the competitor, right? So antifragility is a key term in this whole enterprise cloud native story. The next thing, surprisingly, that has nothing to do with tech, is recruiting. I told you before that, times have changed for those enterprises. 10 years ago, IT was, don't do IT in-house because it's a cost factor. Just put IT and software development, software engineering, towards, low-wage countries. And now they kind of realize that that was a bad idea to do. And in return, most of the IT people working for those large enterprises, they kind of lost their skills to program, right? Or they're losing the good people. So of course it's kind of a a branding thing, like, hey, we do cloud native now, and hey, you cool software engineers, please come and work for us and build our cool products. So recruiting is for sure a valid reason for enterprises to go cloud native. The next thing is speed, and with speed I mean not the system running really fast. Well, that's kind of cool as well. With speed I more mean the development life cycle, right? Go away from 4-monthly release cycles maybe to a 2-week release cycle. Okay, so be faster, get your cool features and your cool ideas out there a lot faster than you used it before. Of course, you heard of those two terms, DevOps, continuous delivery. That kind of goes hand in hand with the speed stuff. If you want to deliver your products more frequently, you have to have more automation. You have to have this, the developers are also responsible for operating the applications they just build, and continuous delivery, continuously pushing this value stream of cool features out to your customers. And last but not least, I think it's not that important, but for completeness, it's the term OpEx savings. So OpEx stands for operational expenses. A lot of the upper management and IT people out there, they think if you push your workloads to the cloud, you will be a lot cheaper. Well, that kind of turns out that it's not as easy as it sounds, right? Because you have to use your infrastructure a lot smarter than you used to do. Otherwise, you're definitely more expensive than you used to be. But in theory, it's possible, to have some operational expenses saving via automation, via higher utilization. If you see this whole serverless movement at the moment, where you only pay when something runs. If no one's using your system, you don't pay anything. So that's all good. Right? Now, one thing I don't see, at least at our customers, is that Go as a language is used that often. If it's used, it's usually used for, like DevOps tooling. You build the occasional operator to run in Kubernetes using Go. That's kind of a, prime language to do that. Or maybe you implement some command line interface tools with this, kubectl and whatever. But it's a bit unfortunate why that is. I can only reason why that is, maybe. I mean, rank 14 is not that bad. And to be honest, Delphi and Object Pascal on place 12, that must be students, right, in a university. Who's programmed professionally in Pascal? I mean, Pascal was my first language back at university, but no one Pascal, okay? So cross out Pascal. SQL is not really a programming language. And Visual Basic.NET on place 6. Do we have the Visual Basic.NET unicorn in here at the Go days? Probably not, right? So let's cross out a few languages, and ta-ta, we're in the top 10, right? So I would say, Golang. So I would say Golang is really appealing, right? If you want to introduce a new language, in a large enterprise, of course, that's not just that easy. Now, maturity often is a key factor for large enterprises. They want an active community, they want stable releases, security patches, no known security issues with the language. And I would say, well, tick. IDE support. Well, developer friendliness, in my experience, and you're probably a lot more experienced than I am, IntelliJ, Visual Studio Code, Goland from JetBrains. There are a lot of IDEs with, proper developer tooling that make it nice and easy, to work with Go as a language. More on the tooling side, you have build tools now with, with the module system. The dependency management is good. You have debuggers, you have profilers. For sure, from a software engineering perspective, there are a few tools that, in my experience, are kind of missing. When it comes to, static code analysis or architecture analysis. But hey, it's good. It's tick. Tooling is fine to be productive, right? And productivity in an enterprise context is a key asset. This is important. The library ecosystem, well, I've been to the meetup yesterday. It's been said there, there's a super good standard library and loads of open source libraries you can definitely use and leverage to, to implement your business problems. Documentation, well, online docs, loads of literature, good books, training available. Also, this is kind of important if you want to start with a new language. Also there, tick. And, well, the integration part, I think this is especially important in an enterprise context. I gave it a tick, even though it should possibly only be a half one. What I mean is, you need good interoperability with, those established enterprise standards. I mean, SAP, SOAP web services, Corba-based systems, in the finance industry, I see a few shivers running down your spines. Yeah, but that's the reality, right? And you have to talk to those systems, otherwise you will not be accepted. Well, I think I found the occasional SOAP library, and with, I don't know, SAP, you can talk to, via endpoints. I haven't found a Corba library for Go. Does anyone know a Corba library? Well, then, you know one Corba library? Okay, excellent. So Corba, tick. Thank you. Yeah? I just haven't found it, so Corba's covered as well. And it's dying anyway, okay? Maybe the good old host systems, right? Anyway, so those are criteria for enterprise usage, so I would say, hey, why not use Go for our next microservice? Now, before we continue, or maybe it's, it's time to implement our first nice thing. Let's say, can you all read this? Yeah. So we say make the hello service. So we go in here, because I'm lazy, I copy a file in here. Okay, I'll show you in a second. So what I just copied is this here, okay? And we'll talk about this code in a second, okay? So this is the code I just wrote, okay? So the usual hello world service type thing. Well, we initialize the module system. Like that. Excellent. So, and well, we should be able to run this stuff. Well, it's not doing anything real, so let's see, right? HTTP get localhost. Let's see if it was 8080. And here we go. Right, so service done. If we want to deploy this, does anyone know the tool draft from Microsoft? Kind of, there's one hand, kind of makes the development flow a little easier. So what I do here is draft create, and then I do draft up. Well, this is kind of always depending on the network issue now. What draft does is kind of detect the language you're using and then kind of, scaffolds the build artifacts you need to kind of deploy something, okay? So it basically knows, hey, there's a Go file in there, so it's probably a Go project. It, creates the correct Docker file for us. It creates an Helm chart, so we could deploy this to Kubernetes straight away. The pushing of the Docker image probably takes a while in the network here. Let's see how long that takes. And then at some point, it should deploy this to my local Kubernetes cluster. So from a productivity point of view, I would say, hey, we're done. So pushing done, releasing application. So let's see. OK, that's all good. And ifk ctl get all. Well, it's not booted yet, the hello service, but here we have the hello service. It created the service for us. So, so I would argue, with the tooling and the language, it's really super fast and easy to spin up a service and get, ready to roll. I'm more in usually when I work for enterprises, more in the Java world, and I promise you it's definitely not that fast, right? Right, so let's go back. I mean, hey, we've just proven that Go is, well, we can implement some microservice type thing in Go, right? And we're done for today, right? Well, probably not. Because this is the code we just deployed, I would say this was not an enterprise microservice. That was some service built in Go that opens a port and it says like, hello world, right? I think there's a lot more to the enterprisey. So what makes a microservice enterprisey? Well, here, Go provides a solid foundation, and that is important, right? Now, let me briefly talk you through some essential cloud-native design principles. Well, the first thing is, when you build enterprise microservices, okay, you have this whole distribution type thing you have to keep in mind, right? So the stuff you have to build needs to be designed for distribution. You will be running in a container, you will have microservices, or even smaller now in the serverless world, maybe function services, and you have API-driven development. Well, regarding the containers bit, designed for distribution, I think Golang is super suitable, right? Low memory footprint, nice, easy, fast startup. I mean, I compare that to a Java world, right? Definitely not a low memory footprint, and startup times are usually pretty high. So you can do like in-container builds, you can use Google distroless images, you have this single binary you put into your container. I mean, that's kind of a dream, right? So that's covered, I would say. Design for configuration. Well, in the 12-factor principles, it says, have one image and push this one image to multiple environments. You have your dev, your test, your int, your prod, your pre-prod, your QA, whatever environment. And it should always be the same image. You should never recompile your application. So what does it mean? Well, for the configuration, I mean, every environment will have different configurations, right? Different endpoint URLs you have to configure, different settings, different timeouts, whatever. So what you have to do as a software engineer is to build those configurability into your service. You need to be able to read, I don't know, Kubernetes config map, YAML files, JSON files, environment files, the command line parameters, whatever, you name it. But we definitely have to do something for this configuration part. This doesn't come for free. Design for resiliency, that's the next big thing, right? Remember the antifragility bit. Also, this does not come for free. We are running usually towards a highly distributed environment, which is good, right? Because this gives us resiliency. Lots of tiny microservices. If one fails, you still have something running. But when those microservices talk to each other, things can go wrong. There can be delays. The other side may not be responding. So you have to do something for the fault tolerance, the self-healing. You have to introduce circuit breakers, bulkheads, proper timeouts, all that. Again, we as software engineers have to do something that our service will become resilient. Design for elasticity. Also here, well, we want to scale up, we want to scale down, and elasticity usually works in both directions. If we have high demand, we scale up. If we have no demand, we possibly scale down to 0 using Knative or some other technology. And we want to scale, but sometimes, we have some form of transient state, and maybe we have to think about, where to put this state, maybe in a Redis database or something. Again, we have to do something for this. Design for delivery. Short round trips, automated provisioning. Well, we have to care for this. This has usually nothing to do with the language itself, but those short round trips, for example, you have to have good dev tooling. You have to use tools like Scaffold or the draft tool I just showed you. So you can optimize your inner development loop and make that more efficient. So, you kind of pay back on the speed aspect of this enterprise cloud native thing. So you're developing, deploying, developing, deploying. Design for performance, well, you want to be responsive, concurrent, and resource efficient. I think that thing is in Go super nicely covered. Design for automation, again, we want automation, because we're usually working in DevOps mode. Again, for automation, what we usually have to do is we have to kind of build something so that the automation works. We have to provide certain endpoints, certain APIs, so we can automate our services. So right here, again, we have to build something. The diagnosability is super important, all right? What you want is cluster-wide logs, metrics, and traces. Again, you don't get that for free, right? In the microservice I just built, well, it didn't log anything. There were no metrics whatsoever. It didn't provide any traces. There was no health endpoint. There was no metric endpoint, nothing, okay? So diagnosability is 0. And this is important in a highly distributed environment, that you have the holistic view on your architecture, on your system. And last but not least, do not forget about security, okay? Secured endpoints, zero trust stuff, encryption, MTLS, end-to-end encryption, all that. Again, here, usually not for free, you have to do something for that. And this brings us to kind of what I call the anatomy of an enterprise microservice, okay? So what you usually have in the center, right, you have your domain logic. Either you do domain-driven design or not, that doesn't really matter, but you have some core business logic that does the stuff your microservice has to do, right? This is usually pretty technology agnostic. This is pure code, right, where you implement the business rules, the business logic, where you have your entities, your domain objects, your structures, and where you do those things. And then on the outside, you usually have kind of a thin service layer, where you implement kind of the use cases that kind of orchestrate all those, all the domain logic. And on the outside now, you have all those cross-cutting concerns you kind of have to implement or have to care for it somehow. So you adhere to all those design principles, or to most of those we just talked about before, right? So of course, you see the orangey part on the top right, where we talk about APIs. Messaging is probably soon very important. Service discovery does play a role. How do your microservices find each other? You have this resilience pit, configuration, coordination part. Then, of course, you have some form of data usually in, sometimes I see those microservices and, hey, look at my API. It can, it can count numbers, or it can add A and B. I have not seen those sorts of microservices in an enterprise. Usually you have some form of data, customer data, whatever, basket data, shopping item data, and so on and so forth. Then you have the security and the logging and monitoring part. Now, I briefly talk you through, for those APIs here, I mean, if we look in the wild now, we probably have to support some form of REST APIs, right? That's kind of, at least on the public-facing APIs you offer to your customers is usually REST APIs. What's a bit to my surprise, but good enough, those are good old RPC APIs, gRPC APIs, they kind of have a renaissance again, right? I mean, look at Kubernetes. On the outside, you have like REST APIs. On the inside, everything is gRPC. Google does it internally the same. So it would be nice for the technology we're using and for Golang and the libraries we need probably to implement this, that we have kind of REST and RPC support. And for good API documentation, Swagger and OpenAPI would be really nice to have this enterprisey touch. You usually need to document your interfaces, and I think Swagger and OpenAPI v3 or the protobuf file are kind of the means to do that. For messaging, right? Again, here, messaging is super old. I mean, the first message queues appeared like, I don't know, like 30 years ago at least. For some reason, I don't see many message-based systems and event-driven architectures out there, unfortunately. Most of the time, you see like synchronously coupled microservices talking to each other. And it may be a good idea to kind of invest in loose coupling and an event-driven architecture. Maybe you're thinking about CQS or event sourcing as a paradigm. So it would be nice if I could do like messaging for asynchronous communication. Discovery, well, pick whatever you need for your environment. Maybe you have console, maybe you're using Kubernetes and then it's DNS. Maybe it's something cloud provider specific. Again, what I'm looking for is for a nice way of integrating with those discovery services. Same here, resilience, circuit breaking, bulkheading. I'm also looking here into, I don't want to implement this, right? I mean, well, it's fun as a couch project, but if I'm in an enterprise context, I don't want to build my circuit breaker on my own. Same here, goes for the configuration. I told you before, you want to push this image to the multiple environments, so you need some form for environment variables. Kubernetes config maps would be nice if you could process them. YAML or JSON files, or static configuration files. Coordination, important. Well, usually if you run your microservice, in a multi-instance fashion, right? 2, 3, 4 instances, you may find that you will need some form of consensus. You may want to run a scheduled task, for example, and you only want to run this, as a singleton. How do you do that? So support for distributed data structures would be nice. Maybe the Raft protocol, or an interface to etcd, so you have this distributed consensus capability. Data management, same here. Relational databases, NoSQL databases, graph databases, time series databases. Whatever, right? I mean, there are a ton of different database technologies out there, and again, here, what I would look for as when I look at the language and the universe and the library universe, I would expect that relational databases and all this is pretty much covered. Elasticity, maybe support for in-memory caches, a client library for Redis or a client library for memcached. Talked about the the security bit. How's it about encryption and signing capabilities in the language or the library universe? JSON Web Tokens, OpenID, all those security-related standards. I would expect, support for those because they're in widespread usage usually in enterprises. Structured logging important, so good old JSON logging, for example, so you can kind of have this holistic view on the logs of your architecture. Health and metrics endpoints, Prometheus et al., all those. And finally, tracing. To sum everything up, open tracing support, either Jaeger or Zipkin would really be good. So you see that when you implement microservices on an enterprise level, there is a ton of things you have to care for. Hopefully not all of them, okay? There will be the microservice that does not have a database, so cross out the data management bit, but all the other stuff is pretty well pervasive through all of them to make up a nice architecture. Now, the question now is, how does Golang and the library universe address all these? I mean, this is why we're here for today, right? Now, in my, then what you do a bit of Googling, right? Golang microservice, and you do a bit of a research. What I found is, it's you have kind of two options in the first place. The first thing I would advise you or recommend to be productive, to have like a nice homogeneous architecture, have a look at either those microservice chassis frameworks or the pure web frameworks. Both very similar. In my opinion, the main difference is that the microservice chassis focus more on RPC interaction. And the web frameworks, I would say their predominant use is, building REST APIs, right? I tried out a few, and it's really nice to work with them. And in only a few lines of code, you can basically, spin up a Go microservice, for example. And, I don't know what those web framework guys are. They must all be alcoholics, right? You have gin, martini, Negroni. Okay, not Gorilla, but the first three, okay? The first three are definitely alcohol. That proves that software engineers like to drink gin. Okay, what they also bring with is not only the RPC bit, so all of the microservice chassis and most of the frameworks, so they have the API bit pretty much covered. Usually they have the messaging bit pretty much covered. So at least the microservice chassis ones, they also support PubSub type communication using, Kafka, RabbitMQ, NATS, all those, fancy message queuing systems. They also have the discovery bit pretty much covered. They can talk to console. They know when they're deployed in Kubernetes. They switch to DNS. They have multicast DNS. So they have different discovery mechanisms also built in. The chassis ones and also the web frameworks, they usually already have a, strong recommendation how to implement resiliency. Either they've implemented their own circuit breaker, which you can use straight away, or they kind of tell you the library that kind of plugs in nicely. So all of them have kind of a plugin system where you can kind of, retrofit those required cross-cutting concerns afterwards that are maybe not standard, right? So definitely make sure, in my recommendation would be, do not build, a microservice framework on your own using like the standard Golang HTTP package, like I did before. Okay, I think this is nice for Hello World, but maybe not so nice or maybe not so suitable for enterprise stuff. You have the community power out there. You have really good, stable, big packages that give you a lot of this cross-cutting stuff out of the box. So time is 10 minutes left. Okay. Well, I think we can. I can show you a bit more code because. Let's see. Well, so I've implemented a small gin web service, and guess what? I've implemented a REST API where you can buy gin. And So we do that. Now, you see here, to fire up the Gin framework, for example, it's this one import, and you're already ready to go. This line here, I basically spin up this, this Gin web engine HTTP server, or I get the engine. The nice thing, for example, about those web frameworks is that they're kind of already pretty well capable of serving static files. Now you might ask, well, why do I want static files from microservice? Well, I would argue that usually what you have is a REST API, and maybe you want to serve your super fancy AngularJS single-page web application with the same instance, right? So you serve your UI, and this UI then straight talks to those APIs your server just offered. And you can super easily do that. You see here, that's the index.html where I kind of talk to my API/gins, which is an API my microservices offers itself. So that makes, in my opinion, those frameworks really appealing, that you can kind of have both things together. REST API plus static serving gives a nice little server for single-page web applications. Now, if you look at this bit here, I think it's pretty much self-explaining. You say, well, dear engine, when there's a GET request for slash, so kind of the index, then please serve this HTML from this index.html file, and this index.html file in this case is even a Golang template, which is then parsed, the data is inserted, and then it's served. So that kind of spits out my, my single-page web application. And then you have this block here. I know, super simplistic, a small CRUD interface to kind of, query for, all spirits or all gins. So if we have the GET request for /API/gins, then we're using this all spirits handler. When we do post, we create one. When we do get for, this parameter here, so Doppelpunkt async in this file, in this case, you say get spirit update. I would say that's super readable, and you can understand that pretty clean. So here you say, in case of all spirits, I say context, JSON, HTTP status OK, and here's my business logic, return all those spirits. Now this is just to show you that, to implement this service, yeah, it's gins and not really business value, but spinning up this gin framework itself kind of takes you 5 minutes, and then you can start straight away implementing your REST API, stick in your business logic. Yeah, I don't have a database here at the moment. Stick in some database framework, which we talk about in a second. To have like some persistence maybe to read those from a relational database, and you're kind of ready to go nice and fast. And again, what I could do with this one here, so let's see, kubectl get pods. So the gin service is still running. Okay, let's see. Then we do draft connect. So again, I've used draft here. What you see in the console now is the output of the fired up container running locally on my machine. So what we can say is http get localhost. What's the port? 49960/API/gins. And here you have it. I'm talking to my freshly deployed, not so hello world type microservice running in my Kubernetes again. Okay, so time to finish. So again, I would say have a look at those frameworks. I'm not going to recommend one. I made good experience with Go Micro, and with Gin, kind of usually that's kind of probably a preference. Do you like the API or not? Is the API appealing to your development team, and then you choose. Or you make a small POC and evaluate two, and then you choose the one which is more suitable to you. Okay, well, I said about databases, and I think, data in databases is definitely important for enterprise microservices. So you need some way of storing. And what I was looking for, you know, when you come from a Java world, you have your JPA, you have so many different standards and libraries where you do like those object relational mapping. And it's definitely comfortable, right? I mean, I don't want to write manually handcrafted SQL, lines of SQL and run into every SQL injection error I can possibly make, right? So I'd rather use a proper object-oriented mapping framework, GORM. So this is like, you know, the Golang object relational mapper. So that's GORM. Well, definitely powerful, I would say. You can do every fancy mapping you can imagine. So basically what you do is you model your table structure using Golang structures, right? You model your one-to-n, m-to-n relations using, you know, using code in standard Go structures. And then what you usually do is you kind of annotate what the column for each thing is, or you use the defaults. So GORM, worth a look at. The second one, this upper I/O, that's kind of really nice because they also have support for NoSQL databases, namely Mongo at the moment. So they support Postgre, Mongo, SQLite, MySQL, and a few others. Again, here, have a look at them and pick one and make your choice. So again, here my recommendation would be do not write handcrafted SQL. Logging, again, you know, pick the one you like best. Logros or this log15 both support structured logging as a JSON format. For the monitoring bit, well, if you have Prometheus as an infrastructure component, then, you know, go for the official Prometheus package, Go package, or you use Go metrics, for example. This is where you kind of instrument your code with, you know, with counters, with how often has this endpoint been counted to have some, you know, business metrics. Or you output some, you know, some technical metrics. My database is down, or my whatever just happened, right? Or mean request time you can record. So things like this, so you can kind of reason about your system and have all those metrics. And finally, for tracing, again, maybe just use the, you know, the standard open tracing Go package, and maybe Jaeger or Zipkin to plug in as the actual tracer. So I would say, I have not covered all of them, but I'm pretty sure that the security bit is also covered and the elasticity bit covered. So from the library's perspective, I would say, hey, everything covered. So that leads me then, you know, to the question, and in my opinion, kind of the answer, is Go and its library universe fit for the cloud-native enterprise? I would say yes, you know, from a, you know, my opinion, from a professional opinion, from 20 years of programming experience, I'm ready, you know, to maybe not use Java all the time anymore and, you know, go down the Golang route. I say yes, but, you know, it's always with the yes, it's a yes but, okay? Because it's kind of still young and the universe is still young compared to all those, you know, big contenders out there in the enterprise universe. What I would wish for is that the integration bit, that, you know, plugging all those different packages together would be maybe, I mean, this is room for development and room for improvement, that someone makes an effort to have this opinionated, even more integrated framework, so that I don't have to retrofit this and this and this and this, and then I have to see if they work together nicely. You know, if you come from a Spring Boot world, you either hate it or love it. But if you love it, it's because you don't have to care for anything anymore. It's just get this framework and implement your business logic. And what I would hope for is that the same happens in the Golang universe. Right. Thanks, and Mahlzeit and some questions I think we have time for. You're all hungry, right? I see. Then thanks. I'm here for the rest of the day, for tomorrow. If you have a different opinion, you know, please come to me and chat. I'd love to hear the Korber story, for example. Thanks.